Today we're going to talk about ratios. Ratios are what we use to scale things up or down. That is when both quantities are getting bigger or both quantities are getting smaller. Let's look at an example for this as we develop the method. Ratios are used when you have two quantities, quantity 1 and quantity 2. It's a situation where you have something where both quantities are known in one case and unknown in another. One of these is unknown. Okay? So let's look at a case where we have a building. We don't know how tall it is. We do know that it has an 18-foot shadow. On the same street, we have a stop sign which is 6 feet tall and has a 2-foot shadow. We can use this information to find out how tall the building is. Our quantity 1 and quantity 2 are building height and shadow. We'll put height as quantity 1 and shadow for quantity 2. Okay, it doesn't matter which one goes where, as long as they're the same going this way. Okay, these two things have to be the same, including units, and these two things have to be the same, including units. We'll look at the units thing a little bit later. Okay, to start out with, our known ones give us a 6-foot height and a 2-foot shadow. Our unknowns, we don't know the height, but we know the shadow is 18 feet. Now, the standard method is to cross multiply. That gives us 6 times 18 equals 2 times x. But to be honest, that's more math than I want to do. Okay? There's a much easier way to do this. What I do is I look for patterns. Okay? In this case, 2 times 9 is 18. So that means 6 times 9 is x. So x is 54. Okay? It also works side to side on the sides. 2 times 3 is 6. 8 times 3, 18 times 3 is 54. Those are a lot easier than the cross multiplication. Cross multiplication will always work, always, always, always. However, 90% of the time it's more work than it needs to be. You can generally get it faster. All right, let's look at another problem here. We're using the Solving Word Problems book. R2, number 1. 5 chickens on the Cluck Egg Farm lay 30 eggs a week. How many chickens are needed to produce 1,200 eggs a week? So we're scaling up the operation. We'll have chickens here, and we have eggs on the bottom. Okay, we have 5 chickens that lay 30 eggs a week. We want to know how many chickens it takes to make 1,200 eggs a week. All right, so chickens, chickens, eggs, eggs. There's a couple different patterns here. We can go that from 30 to 5, we're dividing by 6. So if we divide 1,200 by 6, we get 200. That's one way to solve this problem. Another way, let's put it down here. Another way is to simplify by canceling those zeros. Okay? Then we have 3 going into 120. So that's times 40. 3 times 12 is 4 plus the 0. So 5 times 40 will also give us 200. And then there's the 5 times 12 is 6,000 divided by 30, which also gives us 200, which is the cross multiplying. If you notice when I'm doing this, whether I'm multiplying or dividing depends on which way the arrow goes. Since we are going from the 30 to the 5, we're dividing by 6. If we were going from the 5 to the 30, we would be multiplying by 6. But since we want to go from the bottom to the top, because that's where the x is, we have to have the arrow this way. Okay? Let's do another one. Okay. Next problem is R2, number 2. A recipe calls for 2 cups of flour and a half cup of sugar. How many cups of flour would be required if 3 cups of sugar were used? So we have 2 cups of flour. Let's put flour on the top and sugar on the bottom. 3 cups of flour and a half cup of sugar. How many cups of flour would be required if 3 cups of sugar were used? Okay. First thing we want to do is get rid of this half. Okay, we hate fractions, right? Everybody hates fractions. So we get rid of the half by multiplying by 2. So we're going to multiply this by 2 and either this or this by 2. Okay, so let's multiply this by 2 and this by 2. So now we have 6 over 1 equals x over 3. Okay, when we're canceling or multiplying, we can go up and down and we can go side to side, but we cannot cross that equal sign. We cannot go diagonal, which means we cannot cancel the 3's out of here. Okay? That's because when we cross multiply, we're multiplying these 3's. So let's have a brief digression here. So let's look at this, use this one, and say, okay, what if we, right now what we've got is we've got 6 times 3 equals x. Okay, that's 18 equals x. Okay, so we solved it here. If we cancel the 3 out of each, then we would have 2 times 1 equals x, or 2 equals x. So 18 does not equal 2, which means that we can't do that. Okay, let's go back to in time to where we did not know what this answer was. Okay, now we know that we want to go from 3 to 1, no, 3 to x. So we go like that. So we need to go like this way. So to get from 1 to 6, we multiply by 6. And it gives us 18. Or we could go from this to here, which is times 3. 6 times 3 is 18 again. So either way, the answer is 18. All right, let's look for a harder one. R2, number 6. Auntie Gope can travel 112 miles on 4 gallons of gas. How many gallons would be required for her to travel 392 miles? So we have miles and gas. Miles, gallons of gas. All right, she can travel 112 on 4 gallons of gas. How many gallons will it take for her to travel 392 miles? If you don't like the X on the bottom here, we could swap it so that the gallons are on top, miles are on the bottom. Okay? Either way, they're the same thing. They'll give you the same answer. Okay, I'm going to erase this so I have space. All right, the relationship here is not at all obvious. So let's look at this one. I know 4 goes into 100 and 4 goes into 12. So 4 has to go into 112. Okay, 100 divided by 4 is 25. 12 divided by 4 is 3. So 4 goes into 112 28 times. So let's take 4 out of each. So I have 28 over 1 equals 392 over x. Okay, we can now divide 392 by 28, but I don't like that. That's too hard. So let's simplify. They're both even, so we can take 2 out of both of them. Okay, 39, we'll use our trick from before, 392. This is 38 and 12. 38 divided by 2 is 15, 16, 17, 18, 19, and 6. So this is 196. Okay? We can take another 2 out. That makes us 7. All right, 196. It's just short of 200. It's 4 short of 200. 200 minus 4 divided by 2. So that's 100 minus 2, which is 98. All right, this is getting a little bit messy, so let's rewrite it. We have 7 over 1 equals 98 over x. So we need to find this relationship now. 7 is a prime number, so that means we can't reduce that any further. 98 divided by 7, 1, 4, takes 14 gallons. So that's our answer. But if you notice, we can simplify a lot before we have to do the math. And it's much easier to divide 98 by 7 than 392 by 28. And while it took me a little while to do it here, it's much faster if you're doing it in your head. Okay, the next problem, R2, number 9. If 4 out of 5 students in art class are right-handed and there are 8 left-handed people in class, how many are right-handed? Okay. Quantity 1. The question is, we have left-handed people and we have right-handed people. So we have left and right. All right, if 4 out of 5 people are right-handed, 1 person is left-handed. So we want to make this left, not total. 1. For every 1 left-handed person, there are 4 right-handed people. That's what 4 out of 5 means. All right, and we have 8 left-handed people. How many right-handed people? All right, we can go times 8, 4 times 8 is 32. So there's 32 right-handed people. It's a class of 40. All right. We also could go like this, times 4. 8 times 4 is also 32. It's also cross multiplying gives you 8 times 4 is 32. The trick here is that you want to define your quantities. How did I know what to use left and right rather than total? Okay, I did that by the final question. These word problems, they give you a sentence or two to explain the situation, and then they ask you the problem. They ask you the question. So in this case, the question was, how many are right-handed? So we know right-handed has to be one of them. Right before that, they said 8 left-handed people in the class. So we're given 8 and asked for the right. 8 left, then there's the right that it's asking for. So that tells us we need left and right, not right and total. So that's why we have 4 and 1, not 4 and 5. Okay. Okay, next problem, number 10. Pearl Lee is saving to buy a $341 freshwater pearl necklace. She has saved $124 in 8 weeks. At this rate, how many more weeks will it take her to save the price of the necklace? All right, so she has 341 is our total that we're looking for. She has 124 of it already. Okay, so we'll put money and weeks. So she has 124 in 8 weeks. Now for the unknown, we're asked for weeks, but we're asked for how many more weeks. Not how many weeks total, how many more weeks. If we put 341 here, we will get the total number of weeks, which isn't catastrophic because if you find the total number, you can subtract 8. No big deal. But you have to remember that you're doing it so that you remember to do the subtraction, because otherwise you get the wrong answer, and that doesn't help. Okay, so we can either do 341 here, or we can do the subtraction. Let's put the 341 here, because that's what our normal reaction would be. We just have to keep in mind that we have to subtract the 8 when we're done. Okay? So, once again, it does not look very nice. I can see that we can take out a 4 here. I don't see any relationship right off the bat, but I can see that we can take out a 4 here because we've got a 12 and a 4 on the top and we've got an 8 on the bottom. So let's do that. So that's 31, and this is 2. Well, we can't do anything more with the 31, or with the 2 rather. But I can look at this 31 and see this over here. 341 is 31 and 31. Right? So that makes this, we divide that by 31 and we get 11. So we get 1 over 2 equals 11 over x. So that gives us that x equals 22 weeks. So then we can subtract by 8. We subtract 8, and we get that the total is 14 more weeks. More weeks. Okay? So a lot of it's recognizing the patterns. Seeing that you can pull out 31 and 31 is a big deal on this problem. Let's say that you couldn't see that. In that case, you're stuck doing the cross multiplying with 31. So you do the cross multiplying and get 682 divided by 31. And then you get the 2 here. So 62, and then 62 gives you another 2 there. So that's the way if you can't pull it out of there. Okay, let's do a couple more examples. R4, number 8. Pamphlet read 8 pages in 20 minutes. So we'll do pages and minutes. She read 8 pages in 20 minutes. How much will she read in 2 hours? So we want to know how many pages she'll read in 2 hours. However, this is minutes, this is hours. So we can't do that. We need minutes and minutes. So 2 hours times 60 minutes per hour makes this 120 minutes. Okay? If you're good at pattern recognition, you say, okay, this is times 6. So you can do this as times 6 and get 48 pages. If you didn't see that one, we can simplify it by canceling those zeros, and then go from 2 to 8, you multiply by 4. So we're multiplying 12 by 4 to get 48. Look at that, same thing. Number 10, the 4-cylinder turbo turns at 4,000 revolutions in 2 seconds. So we get revolutions in seconds. The fact that it's a 4-cylinder doesn't matter. It's what we call a distractor. It's a number thrown in there just to see if they can throw you off. Okay? 4,000 in 2 seconds. How many revolutions does it make in 8 seconds? Okay, from 2 to 8 is times 4. So we're multiplying 4 times 4 and getting 16 with 3 zeros behind it. So 16,000 is our answer. Okay. Let's do another one. The scale of the blueprint for the barracks is 1/4 inch equals 1 foot. Okay, this is inches, this is feet. Okay, this is inches on the blueprint. This is feet in reality. If the day room measures 7.5 by 12.5 on the blueprint, what is the actual room size? Okay, we've got two numbers here, 7.5 and 12.5. Okay, that's because the room has 2 dimensions. So what we normally have to do is run this problem twice. Once with the 7.5 and once with the 12.5. However, if we look at our answers, we get that the answers are, let's put them over here, 28 by 48, 37.5 by 62.5, 22.5 by 37.5, and 30 by 50. Okay, because all of these numbers are different, we only have to run it once. Okay, we just have to do the 7.5, and then we can find our answer from that. Okay, we want to know how big it is in reality, and it is 7.5 inches on the blueprint. Okay, so first things first, let's get rid of those fractions, huh? We hate those fractions. So we're going to multiply by 4. Because by multiplying by 4, we can get rid of both sets of fractions. So we have 4 times 1/4 is 1. So we have 1 over 1 equals x over 7 times 4 is 28. Half of 4 is 2. So we get 30. If this is the same, if 1 inch is 1 foot, then 30 inches is going to be equal to 30 feet. So our answer is this 30 by 50. Okay, here's another one where we can do both ratio and proportion. For number 12, a survey indicated 6 out of 10 people were in favor of a non-smoking law. If 2,500 were surveyed, how many were in favor of the non-smoking law? Okay, so let's look at that. We have favor in total, 6 out of 10. We want to know how many is in favor out of 2,500. Okay? We like the fact that this is 10, because that means that to get from here to here, we're multiplying by 250. So 25 times 6 is 150, plus that extra 0, 150, 1,500, or 1,500. Okay? Let's look at it as a proportion. We have 6 in favor and 4 not in favor, giving us 10. We have 2,500. We're dividing that by 10. That gives us our 250 back. And we have the 250 times 6 again, giving us our 1,500. And we go the 250 times 4, 1,000 that were not in favor. Okay, R3, number 11, melodrama. Director of a little theater said the ratio of women to men in his play was 5 to 2. Women, men, 5 to 2. If there are 35 actors in the play, how many are men? Okay, 35 is our total. So 5 plus 2 is 7. So we're dividing 35 by 7 and getting 5. Which means that 5 times 5, there was 25 women. And 5 times 2 is 10 men. So they're asking for the men, so we get 10. Okay? If we were doing this as a ratio, we would say 2 out of 7, because we're looking for men, and we have total, equals x over 35. And then we go times 5, times 5, and that gives us 10. Okay, there's one more issue that we need to talk about with ratios, and that is problems pretending to be a ratio problem that aren't really. For example, if you're following along in this book, R4, number 9. A freight train takes 26 hours at a speed of 35 miles an hour to go from Haytown to Hicksville. How fast must a train travel to make the trip in 20 hours? Okay, remember, ratios make everything bigger or smaller. Okay, so what would happen here is that it would give you a lower speed, because the hours are going down. It will give you a lower speed, and you can't get to the same spot faster by going slower. Okay, so what this one is that it takes 26 hours at 35 miles per hour to get there. So what we need to do is we need to multiply these two. 35 times 26. 35 times 20 is 70. 2 times 35 is 700. Here. 6 times 5 is 30. 6 times 3 is 18, 19, 20, 21. So it's 910 miles. We divide 910 by 20, which is the new time to get the new speed. Okay, 20 divided by 91 divided by 20 is 4. 100 divided by 20 is 5. So we get 45.5 miles per hour. If we had done this in ratio form, that speed would have been slower. So that doesn't make any sense. So we've got to be careful to make sure that our answer actually makes sense by thinking about it. There's one more subject that we need to cover in this section, and that is proportions. Proportions are used when we're dividing something unevenly, or we're scaling something up or down and we want it to be without units. Proportions are used if you own stock. For example, the amount you get as a dividend depends on how many shares you have, and the shares you have are not the same as the shares everyone else has. So we split it that way also. It was also used to divide pirate treasure on pirate ships. So let's look at the pirate ship fast class. All right, the students each have 1 share each, and there's 20 students. So we have 20. The classroom assistants, of which there's 2, each get 5 shares. So there's 10. And as the instructor, I get 20 shares all by myself. All right, so let's see how much everyone gets. We're going to have 20 at 1 and 2 at 5. So what we do is we add this up. So whatever we get, we're going to be splitting by 50. All right, let's say we got $20,000 worth of stolen booty. We divide that 20,000 by 50. All right, let's kill the 0. That gives us 400. So it's $400 per share. Okay. The students each get 1. So the students is 400 each. Okay? Since there's 20 of them, we get 8,000 of our 20,000 goes to the students. Okay? Our assistants, they get 5 shares. So we multiply 400 by 5. So they get 2,000 each. So they total 4,000. And I, as the instructor, get 20. So 20 times 400 . So I get 8,000 total, just for me, because I'm such a good captain of this ship. So what's going on is that we're splitting it unevenly based on responsibility. And it happens this way with corporations too. The fact that pirate ships and corporations both split their money the same way kind of says something there, huh? Anyway. All right, we did another problem like this earlier with the students in art class. There was 4 out of 5 that were right-handed. So we have right-handed and left-handed. 4 to 1 gives us a total of 5. Okay? So if there was 8 left-handed, 8 times 5 is 40. 8 times 4 is 32. So that gives us our numbers again. All right. because there's 8 and 8 is 1 share. So we can just multiply 4 times 8 or 5 times 8 and 5 times 8. Let's look at another example. A guy gives his kids $91,000. Okay, he leaves one of them. It's split 3 to 4, kid 1 and kid 2. How much do each of them get? Well, 3 plus 4, 7 total shares. So we divide 91,000 by 7. 91 divided by 7 is 1, 3. So each share is 13,000. Three times 13 is 39,000. 4 times 13 is 52,000. And if you add this up, you get 91,000. So that's how to handle proportions. All right, I want to do one more proportion one because it's coming from the opposite direction. Jose's recipe for frozen margaritas is based on using a 6-ounce can of limeade as a measure. He says you need 1 can of frozen limeade, one and a third cans of tequila, and 2/3 of a can of triple sec. All blended well with ice. What is the ratio of limeade to tequila to triple sec? Okay. This problem illustrates why we use proportions for a second way. This is a recipe that, while it's based on a 6-ounce can, it can be adjusted to anything. Okay, we can take this word can out. And we can put the word gallon in. And it'll produce the same thing. This allows us to scale things up and down, just like we did with ratios. But this lets us use more than 2 quantities, because we got 3 here. All right? So let's see what the equation actually is, what the ratio is, what the proportion is. Okay? What we want to do is we want to get rid of those fractions. We always want to get rid of fractions, right? Since the denominator in both cases is 3, we're going to multiply everything times 3. All right, that gives us 3 cans or gallons or whatever of limeade, 3 parts. If you ever see the word part in there, that's probably a proportion problem. 1 1/3 times 3 gives us 3 3/3, which is 4. 2/3 gives us 2. So what we have is 3 to 4 to 2. That's our proportions. So you can make this recipe for tequila, for margaritas, with just this. It's 3 of whatever, 4 of the same thing, same unit, and 2 of the same unit. So that's ratios and proportions. All right, here's a more difficult one. A bicycle has a gear ratio 4 to 9, with the rear wheel making 9 revolutions for every 4 the pedal wheel makes. So that means that we've got a bicycle. Let's draw the bicycle. As you can see, my career as an artist is just not taking off. Okay, so we have the rear wheel. That makes 9 revolutions for every 4 revolutions that the pedal wheel, the wheel with the pedals, makes. Okay, so that's what's going on there. Whenever you're in doubt on anything, reading these problems, draw it. It makes a big difference because you cannot get the right answer if you don't have the right picture. Okay, so our quantities are going to be the rear wheel and the pedal wheel. And we have 9 and 4. Okay? If the rear wheel makes 432 revolutions, how many times does the pedal wheel go? Okay? So 4 and 9, there's not a relationship that we can work with there. We know that it's a little under half. So we're going to be looking for something around 200. That gives us a ballpark to look at. If you are in a hurry, you look at the answers, and they are 192, 15,552, 360, and 972. Okay, this one is right out. It's way too high. This one's too high as well because we're going to be cutting it almost in half. So I'm guessing the 192. Let's see if that's true. Okay. 4 plus 3 plus 2 is 9. So that means that we can divide that by 3. So let's divide it by 3. Divide the 9 by 3 and this by 3. Then we get 3 over 4 equals 1. We get 13. It's 444 over x. We could take that another 3 out. Okay. Alright, that gives us 1 over 4 equals 14 divided by 3 is 4. We have a 2 left over, so we have 24 divided by 3 is 8. All right, so now we can either say multiply by 4 this way, or we can say cross multiply this way. Either way, we're getting 48 times 4. 4 times 8, 1632. 4 times 4 is 16, 17, 18, 19. There's our 192. All right. But if you are on a test and your time is short, you do a little bit under half. So a little bit under half. That will give you 192 straight off. You hit that and you move on. Okay? Hopefully this lesson has given you some insight on ratios and proportions. Tomorrow we will be working with measurements and conversions. I'll see you then.